Hi all, welcome to TutySpot. In this video, let's discuss about LEX tool or LEX language or Lexical Analyzer Generator. LEX is a language used for specifying lexical analyzer. We already know that lexical analysis is the first phase in the phases of compiler. The lexical analyzer reads the characters received from the source code and groups those characters into meaningful sequences called lexemes. Then this lexical analyzer converts the stream of lexemes into the stream of tokens by removing white spaces and comments if any. LEX is a tool or language which is useful for generating lexical analyzer. And it specifies regular expressions. And those regular expressions are used to represent patterns for tokens. And we already know that the token can be an identifier or keyword or operator or a constant. Let's see how to create lexical analyzer with LEX language. So we are giving source program lex.l as an input to LEX compiler. In lex.l, L means the extension of LEX program. Then the LEX compiler compiles the LEX file and produces lex.yy.c file. Here C states that it is in the C program. Then lex.yy.c program is given as the input to the C compiler. Then it gives object or binary file a.out as output. A.out is the lexical analyzer program. So this lexical analyzer takes the stream of input characters and produces a stream of tokens or sequence of tokens. This is the process of creating LEX program. Next, let's discuss about the structure of a LEX program. LEX program mainly contains three sections. First is declarations, next is translation rules, and third one is auxiliary functions. We have to create LEX program by following the structure. The LEX program structure starts with the declarations, then the translation rule starts with %% and ends with %%. So the translation rules has to be written between the pair of %%. One states the beginning and the other states the ending of the translation rules. Next we have to write auxiliary functions. So this is how we have to write the LEX program. So let's discuss briefly starting from declarations. This section includes declaration of variables, constants and regular definitions in C. So if we want to declare C variable or constant, we use % left curly brace and % right curly brace. Between these curly braces, we have to declare variables and constants. Let's consider an example. We have a, b, that is two variables, and assigning constant count is equal to 0. So the LEX program by including data types int and float will be as starting with % and left curly brace, assigning variables int a, b and constant float count is equal to 0 and ending with % and right curly braces. Likewise, we can declare variables and constants in the LEX program. And to declare regular expressions, no need to use % and curly braces. Let's see an example by taking some digits. Minimum digit is 0 and the maximum digit is 9. So the regular expression for digits is as digit 0 and 9 within the braces. And for letters, we can use lowercase letters small a to z and uppercase letters capital A to z. So the regular expression is letter within the braces small a to z and capital A to z. Next, coming to the translation rules. As we discussed before, translation rules has to be written between a pair of %% symbols. Syntax for this is a pattern followed by action. Here the patterns are regular expressions or regular definition, and action refers to the segments of code, that is C language statement. Patterns and actions are separated by a single or multiple white space characters, means blank space or empty space or tab space characters. Here we have three rules, so let's see about it. Starting with % symbols, pattern 1 followed by within the curly braces, action 1, pattern 2 followed by within the curly braces, action 2, and pattern 3 followed by action 3, and ending with % symbols. It specifies that we have three patterns with corresponding actions. If the token or string matches with pattern 2, then the corresponding action 2 will be executed. Likewise, same with pattern 1 and pattern 3. And we have to write each pattern in a new line. Next is auxiliary functions. All the functions which are needed are defined here. Let's discuss about it in detail with the help of a program. LEX program to recognize identifiers, keywords, relational operators and numbers. Let lex.l is the name of the file. Here there are no any declarations, so we can skip percentage and curly braces part. Else if we want to place it, then we can write it with some comment, but the comments will not be compiled or executed. So percentage, left curly brace and comment LEX program to recognize token and closing with percentage and right curly brace. Usually identifier starts with a letter followed by any possible letters or digits. So we wrote letter, lowercase a to z and uppercase a to z and digits 0 to 9. So let's see the regular expression for identifiers. Underscore is not necessary because we are using Pascal language. Place letter within the curly braces followed by any occurrences of letters and digits. This is the regular expression for identifiers. So for identifiers, regular expression is completed. No need for keywords and relational operators. And next is numbers. So let's see how to write a code for numbers using int and floating point numbers represented in fractional and exponential notation. The regular expression for numbers will be within the curly braces digit with plus symbol followed by within the parenthesis dot and within the curly braces digit and plus symbol. And this expression is represented by question mark. Means we can perform this expression 0 or 1 time. Next, open parenthesis, e means exponent. Next, plus or minus symbol and question mark means this expression can be executed 0 or 1 time followed by digit plus symbol within these curly braces and the closed parenthesis and again question mark for 0 or more occurrences of this expression. So this is the first definition section of the LEX program. Next, translation rules section. It starts with percentage and ends with percentage. So first start with the identifier and it is written within the curly braces. Curly braces here is not mandatory because it is the pattern and the action should be within the curly braces. So printf percentage is an identifier and display the token name as YY text, parenthesis close and semicolon and right curly brace. Here YY text is the name of the identifier. Next have to write the code for keyword. We taken two keywords if and else. First here if is the keyword, then printf percentage s is a keyword and then specify the name of the keyword as YY text and similarly write for else keyword. Else and then action printf percentage s is a keyword and the name of the keyword YY text. Next have to write code for operator. Here we took 6 operators. For less than operator, code will be as less than and action within the curly braces printf percentage s is a less than operator and in order to display that name YY text and braces closed. Similarly write for remaining all the operators. Less than or equal to action is person s is less than or equal to operator and to display the name YY text and greater than action to display the name YY text and greater than or equal to is the pattern and action YY text and equal to and action YY text and close braces. And for not equal to, the action percentage s is not equal to operator and YY text in order to display that name. Next have to write code for numbers within the curly braces numbers, then printf and same process within the parenthesis percentage s is a number and to display name YY text and close the braces and end the translation rules with percentage symbol. Next we have to define auxiliary functions, but here in this program there is no need of auxiliary functions. So this is our LEX program. Let's give some input to our LEX program and check. Suppose give the input as Amir is 1, 2, 3 if else and greater than operator. The string Amir is an identifier, so identifier function will be executed. Percentage s means Amir. So Amir is an identifier will be printed as output. Next is. It matches with the identifier. So is an identifier will be printed. Next 1, 2, 3. It is a number. So 1, 2, 3 is a number will be printed. Next if. It's a keyword. So if is a keyword will be printed. Next else. It is a keyword. So else is a keyword will be printed as an output. Next greater than. It's an operator. So greater than is an operator will be printed. This is all about LEX tool or Lexical Analyzer Generator. Thank you.